Let me first give you a relation R. There, R equals A comma B such that A plus B is divisible by 2. Now this relation is defined on set A. And what is set A? There, 1, 2, 3 and so on till 8. Now what are we going to do with this relation? We are going to check whether this is an equivalence relation or not. So firstly, let us understand what exactly is an equivalence relation. A relation is said to be an equivalence relation if it is reflexive, symmetric, and transitive. So let's start by checking if this relation is reflexive. If A comma A belongs to R, for every A that belongs to set A, then the relation is said to be reflexive. So look at relation R. Look at set A. Let's start. Let's say A is 1. Then what would be A comma A? That would be 1 comma 1. And let me tell you one thing. 1 comma 1 belongs to R. You want to know the reason? 1 plus 1 equals 2 and this is divisible by 2. Similarly, if A is 2, then what would be A comma A? That would be 2 comma 2. And 2 comma 2 belongs to R. For the same reason, 2 plus 2 equals 4 and this is divisible by 2. So in this way, it can be seen that if we take any element A of set A, then A plus A will always be divisible by 2. And hence we can say that this relation is reflexive. Now let's take the symmetry of this relation. A relation R defined on set A is said to be symmetric if A1, A2 belongs to R, implies A2, A1 also belongs to R. Now to check the symmetry of this relation, let's take any element of R, let's say 1, 3. Now clearly 1, 3 belongs to R because 1 plus 3 is 4, which is divisible by 2. Now what about 3, 1? Let me tell you one thing. 3, 1 also belongs to R. Same reason, 3 plus 1 equals 4 and this is divisible by 2. So this means that relation R is symmetric as well. Now let's check the transitivity of R. Now a relation R defined on set A is said to be transitive if A1, A2 belongs to R and A2, A3 belongs to R, implies A1, A3 belongs to R. Now to check whether relation R is transitive, we need to take any two elements of R. Let's say we take 1, 3 and 3, 5. Now 1, 3 belongs to R as 1 plus 3 is 4, which is divisible by 2. What about 3, 5? That also belongs to R as 3 plus 5 is 8, which is also divisible by 2. Now look at the two elements. Let me take 1 from this element and 5 from this element. So I get 1, 5. And what about this element? 1 plus 5 equals 6. 6 divisible by 2. And this means that 1, 5 belongs to R. This means that R is transitive as well. So now we know that R is reflexive, symmetric, and transitive. And this means that relation R is an equivalence relation. So whenever you need to check whether a relation is an equivalence relation or not, check its reflexivity, symmetry, and transitivity. And if these three conditions hold, then you can say that the relation is an equivalence relation.